Nagraj. He is currently working as assistant professor in the Department of Chemistry, Anna University, Chennai. Earlier, he worked as a scientist in charge at Spices Board of India for 5 years in research and development and also in quality control laboratory. He has finished his PhD in organic chemistry at IIT Delhi. He has also done his MSc Chemical Science at Pondicherry Central University. He has published 6 papers in international journal and also participated several international events in India and abroad. He has attended several conferences and delivered lecture as keynote speaker and also undergone 12 training programs. His area of research interests are isolation, synthesis of natural products and evaluation of their biological activities, carbohydrate based natural product synthesis, enzyme catalyst organic synthesis, green chemistry, medicinal aspects of spices and spice products.
Welcome to UGC lecture series in Polymer Science. Today we are going to see some of the two polymers and their special properties and application in details. Content of the today lecture is speciality of specific polymers, polyamide, especially nylon 66, properties and its application, and PMMA properties and its uses. PMMA nothing but polymethyl methacrylate. These two polymers we are going to study and their properties and uses in details. So, overview of the special properties of polymer is choosing a material for a specific application. Generally, the least expensive material that will do the job is chosen. That means, we are choosing the material which should be least cost wise, it should be very less. That kind of material will be chosen for the application of the polymeric material. When searching for the right resin for the job, many factors will come into play and they are all will be balanced against the cost. So, cost is a very important factor, and factors such as dimensional stability, service temperature range and impact strength. These three properties are very important in order to get the polymer which is suitable for the industrial application point of view. And the engineering plastics are typically chosen for their superior properties, but if a commodity plastic can do the job, it is the obvious choice. Compared to engineering material, we are replacing with some kind of plastic material or polymeric material which can replace the engineering material which low cost, and whatever the factor which we have seen in the 3, it have to obey all the 3 in order to fulfill their properties and need. So, families, there are 6 basic divisions of the most common engineering polymers, but there are many more subdivisions which available. After that previous lecture series, we have seen already 3 polymers and their structure, properties, application, etc. And today in this lecture, we are going to see exclusively 2 polymers, which is again a kind of engineering polymer and their applications in details. Namely, number 1 is the polyamides, nylon 66 or 6 etc. and the second one is polymethyl methacrylate, generally known as PMMA or acrylic. So, these two we are going to study in details. The first one is polyamides or nylon. The history: developed in 1930s, the DuPont by Walla Crothers and his team of researchers, nylon has proven to be a versatile and valuable thermoplastic polymer. What is the meaning of thermoplastic polymer? While if you are heating it, it have to be get melt and you can remold it, or whatever shape you want to make it, you can do it. So, this is thermoplastic. So, the structure of polyamide which is shown here, this is a nylon 66 where 6 is represented by 6 number of carbon and another 6 represented by another 6 number of carbon which is connected by amide group. That is why which is polyamide. The chain is extended will give polyamide. The polyamide again depend on how it is produced. The structure and arrangement of the atoms in the molecule will differ. There are many different types of nylons which is available. Example shown here is a nylon 66, whereas apart from this nylon 6 and nylon 10, nylon 12, nylon 66 and nylon 6 by 12, nylon 6/3 etc., which is available in the commercial purpose. The number nothing but which indicates number of carbon connecting between the nitrogen and the carbonyl, that will give these kind of numbers. Example here 1, 2, 3, 4, 5, 6 carbon which is attached to nitrogen. Again this is 1, 2, 3, 4, 5, 6. So totally 6. The meaning is 6 carbon here, 6 carbon here will make 1 unit of monomer in the polymer unit. The way they are named has to do with the number of carbon atoms in the monomer. Nylon 6,6 in the previous slide has 6 carbon, a nitrogen separator and then 6 more carbon, which will give nylon 6,6, which I already explained in the previous slides. Polyamides nylon, the density is, especially for polyamide 6,6 or nylon 6,6, is around 1.14 specific gravity. Crystallinity is a physical property of the material which is typically which is 50% of crystalline. That means rest of the 50% which is in amorphous status, only 50% will be crystalline. Crystalline structure nothing but the structural arrangement in proper arrangement will be there, whereas in case of amorphous means random arrangement of atoms or molecules which will give amorphous solids. Hygroscopic property, again polyamide 6,6 should be dried at 180 Fahrenheit for 2 to 5 hours until it reaches the moisture content less than 0.2%. Can be over dried, which will make it more viscous. So drying should be optimum, especially 0.2% to 0.02%, which will be ideal. And the glass transition temperature 135 Fahrenheit, whereas melting temperature is 510 Fahrenheit. Price is around 1.8 pound per polymer. And mechanical properties, especially good to very good properties, but the properties are dependent on what type is used. Another average advantage of nylon is that they are very easily modified by adding fillers and fibers to increase their properties. So mechanical properties nothing but the strength of the polymer, which can be what kind of polymer or nylon which we are going to use, which will varies, especially if you are adding thinner or filler, which can increase the mechanical property. And another one is chemical resistance, very good to excellent. Being a semi crystalline helps out. Their one big weakness is the strong acid and base. So crystalline structure which is more stable towards acid or bases compared to amorphous. Amorphous solid can easily dissolve in case of acid or base, whereas crystalline solid it won't be dissolved that much easily, which will have a strong very good chemical resistant properties. The next one is optical properties. Nylon doesn't have very good optical properties, being semi crystalline makes it translucent to opaque. So compared to optical property, which is not a very good optical property, because which is act as a translucent. If transparent, then it is a very good. So which is a crystalline structure which is also good in optical property, whereas which is a semi crystalline where half of the material which is in the form of amorphous, so which is not good optical property. And flammability, typically nylons tend to self extinguish when burned, so which is flammability properties there. Similarly electrical properties, nylon possesses excellent electrical properties. It is commonly used in a wide variety of electrical connectors. Example shown here, this kind of connectors or chips can be made from nylon 6,6. And weatherability, processability, thermal sensitivity. In case of weatherability, nylon doesn't weather well when it is not modified to resist UV light or ultraviolet light. It also experiences property changes with the changes in humidity. When there is a very low humidity, it can get brittle. So weatherability means humidity is very low, and then that start getting brittle. The breakability are broken. The humidity increases, decreases means this breakage of this kind of polymer will increase. The next properties is processability. It can be difficult to process nylon due to its low viscosity when melted, but it proceeds heavily in injection molding and extrusions. So, processability property, it is not that good compared to other polymers, whereas thermal sensitivity, nylon is very thermally sensitive and will degrade easily if kept too long at a temperature above its comfort range. So, it has even been known to turn brown if left in a dryer for too long at 180 Fahrenheit, which is well below its melting point. So, thermal sensitivity also less if you are prolonged heating will damage the polymer. If you are keeping it for even though low temperature, if you are keeping it for long time, which again will change the property and structure of the polymer if you are heating. So, thermal stability relatively low compared to some of the polymer we discussed in the previous class. And the next one is decoration and assembly. Nylon can be difficult to assemble with some of operations which rely on frictional heating. Its very low viscosity causes it to flow quickly away from the well point and it freezes quickly once away from the source of the heat. It is one of the few plastic material that can be dyed once it has been molded into it, can be decorated by most standard process. Decoration assembly especially which is used having very good application. And another property is creep. Its crystallinity provides nylon with the good to very good creep resistant, and again the recyclability. Nylon falls into the other bracket 7, which indicates that not commonly recycled for any specific purpose. So, this also again come under 7 category, which is not frequently recycled during the process. Again, polyamides applications. So, this is the typical example shown here where nylon 66 used as a very good more strength rope, especially consumer goods. Nylon is used for a wide variety of consumer applications ranging from cookware to rope to gears and bushings to of course women's hosiery. And this is again another class of applications were used in the medical field. Nylon does not show up and lot of medical applications, but it does not have some. Many times those applications deal with nylon in the form of fabrics instead of molded component. Hair and beard nets and blood pressure cuffs are of a couple of example where used nylon 66 in the medical field. Then again another class of application is automotive industry and packaging. In case of automotive industry, nylon is used in many under hood applications like radiator end housings, and it is also used for many automotive electrical connectors. Nylon belts are also used in many tires. And in case of packaging industry, other than wire or zip ties, nylons used in packaging are limited. It is however being used in many multi-layer bottles and films, especially those what contain foods that require an excellent oxygen barrier. So, normally food packaging is the we need very good barrier, it should not pass through any air, especially oxygen, which will enter in the package, it will damage the food. So, better it is not advised to use in case of food packaging except to few application, other things not advisable. In case of construction field, nylon fabrics and ropes are commonly used in the construction industry, but due to its poor weathering characteristics, its other uses in the industry are limited. So, for tying purpose, nylon rope is a very important one. Apart from that, there is not much use in case of construction industries. The next another class of polymer is polymethyl methacrylate, generally known as PMMA. The history of the polymer is the first acrylics were developed in the early 1800, but acrylic we know today. Polymethyl acrylate was not polymerized until 1877 by German chemist Friedrich and Paul. It is a general molecular formula where olefin bond, one of the double bond which is functionalized to one side hydrogen, another one side methyl, and carbonyl again methyl. So, polymethyl methacrylate. Again this is another class of polymer where used in engineering field. PMMA is commonly copolymerized with other monomers to add impact resistance, to improve its heat resistance and add stability for the processing. We already discussed what is a copolymer is two different polymer monomer, two different monomeric unit which can undergo polymerization will give copolymer. So again PMMA belongs to copolymer where two different monomer unit mixed together to produce a polymer. Compared to price, at the time of price around maybe 1.15 per pound, and mechanical properties again very good mechanical properties. It is a very strong and stiff, but it can be brittle if it is not modified or if it is doesn't have sufficient thickness. So that is what, if you want to do more mechanical strength, you have to do the modification. Either you have to add some filler or extender or thinner in order to improve its mechanical properties. If it is a thickness also, you can another way to improve the mechanical properties. Very thin means it can get break at the sometimes. In case of density, PMMA has a specific gravity of 1.16 and the crystallinity is amorphous. There is no crystalline structure which is available, and in case of hygroscopy should be dried at 180 Fahrenheit for 2 to 3 hours or until it reaches a moisture content of 0.04%. So glass transition temperature is 220 degrees Fahrenheit, whereas melting temperature is 410 degree Fahrenheit. So typical example shown here in the picture where chemical resistance of PMMA, as with most amorphous engineering thermoplastics, chemical resistance is the weak spot. PMMA is known as stress cracker and will dissolve or weaken significantly when exposed to solvent. So you can see the picture where this kind of crackers are available. So this kind of small cracker is due to the formation of amorphous crystal in nature, which is not chemically stable. It can easily dissolve or get cracked using weak acids or base which can make damage over it. So then optical properties, excellent optical properties, clearer than glass. So which is a very good optical property compared to polyamide or nylon. Again this is due to the crystal which is amorphous in nature, so which is giving very good optical properties. The next one is flammability. PMMA is flammable, it will continue to burn and will drip, so which is again easily catch fires and it can flammable. Electrical properties, although PMMA is a good insulator, it is not well known for its electrical properties. There are many other engineering plastics that have superior properties and are more easily processed into required configurations. So which is again is a good insulator, but not much research or studies which deals with electrical properties as far as which is used as some kind of insulating material where we can use it for any kind of electrical properties. And weatherability, processability, again the excellent weatherable resistant, excellent weather resistant. The most common problem due to weather is UV light damage, and with PMMA almost all the damaging light passes through without damaging the polymer. So that means UV light which is again radiation from white light, the ranges vary from gamma rays to radio wave. UV one of the again a region which can damage this PMMA polymer. And processability, the most common method of production of PMMA is through extrusion, but it can be injection molded, blow molded and thermoformed. It doesn't process as easily as many other material, and special care needs to be taken with the design. So again processability also it is not easy and compared to polyamides, or previously we studied that all amides, because of which is follow in the copolymerization process, whereas other polymers going normal process. Next properties are thermal sensitivity. PMMA is good to very good in terms of thermal sensitivity. Its rigid backbone resist creep and it can tolerate fairly long residence times. So thermal resistance which is relatively high compared to other polymer, because the side chain present in the polymer. We have already seen in the structure, one side methyl and another the same carbon which is having carbonyl acetyl group, which is more substitution present, the molecule have be thermally more stable than the other previously we have studied polymer. In case of decoration and assembly, PMMA is easily decorated and assembled using most available methods, but special care needs to be taken when using paints and inks that are solvent based. It is very easily colored. What is the meaning is, it's easily decorated, you can easily do the decoration in PMMA, especially with paints or inks, whatever the coloring agent, that will easily absorb color and it will show the color whatever color we are giving. So, some of the pictures shown here where the decoration and assembly here, whatever the different colors if you want to make, you can do the coloring agent, add into the polymer which will make whatever color you want, that kind of color you can make. And if you are not adding any color, you will get a pure white one which is colorless in nature. Again another property is grip one and recyclability. PMMA is rigid backbone, resist grip under normal temperature conditions, and recyclability not as commonly recycled as other material, it falls into the 7 or other category. So, again like nylon 66, PMMA also not going to do the recycling because frequently compared to other polymer, which is once used then which is not going to be recycled frequently or efficiently. Next we are going to see the application of PMMA. In case of consumer good, PMMA's use in consumer goods is usually limited to items like decorations, lighting fixtures and aquariums. It can also be used to make tables, sinks and wash basins. So, these are the applications which is available PMMA, especially in the field of consumer goods. So, some of the pictures shown here where this kind of transparent glass materials which can be made from this kind of PMMA as applications. And another class of application in the field of medical applications, PMMA is implantable in the human body. It is commonly used for implantable optical lenses and for hip replacements. So, implantable material means we can fix in the body, over a period it will get absorbed in the body. So, such a way we can make a lens, especially for eye, we can keep a lens, and hip replacement, especially hip portion. These two area where this PMMA used in field of medical. And next one is automotive. Some of the first use of PMMA were canopies on fighter planes, but they are not used in automotive applications as windshields, at least not in America. The most common automotive application is in the lighting fixtures. So, light fixtures where there only it can have lot of applications, whereas where it is a canopies in fighter planes also, which is used in the previous times, not regularly used in automotive industries. So, the picture which is shown here again as a class of automotive industry where the PMMA is used here. Next another class of application is packaging. PMMA is not commonly used in the packaging industry except in very high end applications where the cost is justified, like in cosmetics. So, again I told you about this packaging industry. Packaging is the one of the very important field where you can take food material and which is easily decomposed or spoiled material. If you want to make it process and you are going to transport to some more place where which is not available, and during the duration of the time it should not get any spoil. So, number one criteria is the food material which should free from contamination, and the second one is packing material. The packing material plays major role. Even though the food is preserved and kept nicely, if the packing material is not good, what will happen due to air movement, the oxygen can go and attack the food material, it can make it spoil. So, in order to prevent the packing material should be very thorough, and it should be have very good property. Again, it could act as a barrier towards any air or especially oxygen, so that the air or oxygen doesn't enter to the food material. We can safeguard the food material. So PMMA is not that much good material in case of packaging, and in case of construction field, again PMMA is commonly used for skylights and any other glass replacement. It is also used for many outdoor signs. So in field of construction, only which is used for kind of decoration items, not in the construction material. So again we can use it as a replacement for glass and etc. So here we have shown here some of the outline or the construction where the PMMA used in the replacing glasses, something etc. like that. So summary, what we have discussed here compared to earlier, we have studied 3 polymers, engineering polymers, and all of them having special properties, and compared to those properties we can see whether these 2 polymers have good or very good property or some kind of property, especially nylon. In case of tensile strength, which is 8000 psi, PMMA having 10,000, so which is having more property, especially in case of tensile strength. And tensile modules 175,000 and whereas 400,000. So again this is compared to this one, which is again having very good properties. In case of chemical resistant, nylon having very good chemical resistant, whereas PMMA having moderate, because which is made up of, already discussed again, which is 50% crystalline form in case of nylon, whereas this PMMA fully amorphous in nature. So amorphous crystal can easily dissolve, so it doesn't have any chemical resistant, that is the meaning. And again optical property, nylon is a poor because of 50% crystalline and 50% amorphous, so the optical property which is very poor, whereas in case of PMMA, which is having excellent optical property because of which is purely amorphous in nature, not in crystalline form. The amorphous because of forming due to formation of copolymerizations. And the flammability, again very good flammable property which is having nylon, whereas in case of this one PMMA having moderate flammability character. Again electrical properties, nylon having very good and PMMA having good, because electrical property purely depend upon the arrangement of structural arrangement. So in case of nylon 50% of crystalline and another 50% are amorphous. So the nylon which is having, because of the crystalline arrangement, the electrical property which is having somewhat better, whereas in case of PMMA which is an amorphous totally, so which is doesn't have any that much electrical conductivity compared to nylon, so which is relatively low, whereas in case of weathering which is a poor, which is excellent weathering property, in case of nylon is small, and PMMA having very good. And the processability, again both are moderate, because compared to other previous class we have discussed polymers, these two are very low processable or moderate processability. Creep resistant, again both of them having very good creep resistant. And again recyclability, I already told both of them comes under other class or 7 in bracket, which indicates that we can't use or recycle frequently these polymer for the further commercial purpose. So again which is a recycling property, which both of them having moderate in nature. These are the questions in this lectures, difference between nylon 6 and nylon 6,6, where we have seen lot of nylon series. So what could be the difference here? And again write the short note on polyamides, nothing but nylon 6,6, properties and applications. And similarly use PMMA, polymethyl methacrylate, properties and its uses. Within this we conclude the sessions, today lectures. Thank you.